Alright. So, we're going to do special right triangles. Yeah, they're right triangles that are special. That's pretty neat. Okay. So, there are two kinds of special right triangles. We'll have what we call 45, 45, 90 and 30, 60, 90. These are going to be our two kinds of special right triangles. Our two kinds of special right triangles. Now, on this, if these two sides are what? Congruent. How do we know that?
Because they have the line.
They have the line, okay? So that means it's an isosceles triangle. And what do we know about this angle and this angle? The angles opposite those congruent sides. They're going to be congruent, right? So could we know what their measurement has to be?
45.
How'd you get 45, Ian? They're congruent. Okay, so why does congruent mean they have to be 45? Why couldn't they?
They're equal.
Okay. So why couldn't they be congruent at 50? Why couldn't they?
If it equals
It'll go over the 180, right? Because we already have 90, so we can only have these being 45 degrees, right? So this is what we call a 45, 45, 90 triangle, where the angles are 45 degrees, 45 degrees, and 90 degrees.
45 degrees.
And so on this one, we have the same setup on 2, where these are going to be 45, 45, 90, 3 same setup, 4, 5, 6. So they're all what kind of triangle? 45, 45, 90 triangles, okay? So what's the direction say right above here?
So as far the length of the hypotenuse of each isosceles right triangle is the first radical.
Okay, so we have 6 isosceles right triangle. We're just combining the word. We're combining the isosceles with right into one definition: isosceles right triangle. We have 6 of them here, and on each of these, we're given one of the legs, correct?
Yeah, so the other one's equal.
So we know the other leg. So could we find what the hypotenuse is? I want you guys to find our hypotenuse on each of these. So go ahead, go through Pythagorean theorem style, simplest radical form. Find this hypotenuse of each one. I appreciate that. If you need help, if you have questions, that kind of stuff, you should ask. If you need a calculator, maybe go get one.
Or you choose one.
Sure. And then, yeah, we have a table down here, right? So I want you to fill those in, okay? So number 1, the leg is 3. So whenever you, like number 2, the leg is 4. And fill in the hypotenuse. Didn't want to hear it, now it's stuck in your head. Yeah, she's like saying it in advisory today. Did you possibly listen to those things out of my head? Did not get out of my head. Yep. Yeah, she broke your arm. Gotta do it to her. Great.
I'm sensing a pattern, Mr. Caution.
I sensing a pattern.
Are these two right?
Yep.
I found a pattern.
This one gets more, yeah.
She does.
And like talking like this.
Try simplifying that one again, okay? This is already asking if they were sent down. Thank you, Pancreas. Well, thank you for not hitting L1.
You bought me Cheez-Its and you like tried to milk it for like 2 weeks. And I didn't want to.
Is that sandwich like inflicted on people?
The way I look at it is, like for this, so square root of 18. I still have to come to meetings.
Wait, what do we have to do? Is it like President's Day?
Yes, we get to honor our Lord and Savior Big Chungus.
I'm drunk. Get this right. Yes.
Great.
This one looks good too.
Wait, what
Ooh,
is it?
Finger.
It's God.
Could be.
Did I get it right?
Ooh, it changed. Big.
I kind of figure what
Yes,
it's gonna
yes,
be though.
yes. Yep. Square 16 square 4.
Oh, wait,
Oh, it's not that.
Ooh, it's not that. I'm Mr. Coffin.
He did that to me too.
No, so don't forget the last one. That was a good.
Whoa.
That's a win right
See
there.
the pattern. Yeah, so why are we
No.
filling them all? Because I'm trying
Oh, that's the
to be a
pattern.
good student
I
here.
told you there's a pattern.
I try to be a
That's
good
not the
student
pattern,
here.
it's
I'm
just like
Kaylee.
square
Hi,
root of
Kaylee. It's nice to
I was
meet
like,
you.
no. Oh, and your brain is so swollen right there. Square root of 8.
Oh, like the square root of 4.
Yep. So go again. This is right. This is right. This is right. Okay.
Think.
Do I just write 2 and 2, or should I put
2
I only
times.
did the first two.
Yeah, so
So you
put
put
a little.
yep, and then actually multiply.
Oh, so
4 times square root of 2. Okay, so it's the square root of 4 times the square root of 2. Because 8 is 4 times 2. So the square root of 4 times the square root of 2. That's normal 2.
Times normal.
Donkey Kong. Donkey Kong versus
No.
Big Chungus. Who's on the front?
I see the pattern, but I kind of want to know how to figure out why.
Mr. Cosmo. I got this wrong because I feel like he did.
Yeah.
Am I supposed to like?
Okay, I'm not adding anything. Okay, so.
Did you even get that photo? Rallies in my diva.
ruining the fun. What part of that can't you understand? I heard
Gauge. For triangle number 1, what was your hypotenuse? 3 square root of 2. The leg was 3. The hypotenuse ended up being 3 square root of 2 after we did our math. On the second one, the leg ended up was 4. What did the hypotenuse end up being there, Noah? 4 times the square root of 2. What was the length of the leg on 3, Faith? What was the hypotenuse? 5 times the square root of 2. What's the leg on 4? Evan.
6.
What's the hypotenuse?
6 square root of
6 square root of 2. Ian, what's the leg on 5?
7 square radical 2.
That's the hypotenuse, right? Would be 7 radical 2?
Yeah.
So the leg was normal 7. Owen, what would 6, the leg on 6, what was that? What would the hypotenuse be?
12 radical 2.
Did we notice a pattern here? Hey! Once you notice that pattern, does that become a little easier? Okay?
Just a tad.
Now, do we think this is going to be just a happenstance on these? Like it was only these 6, 45, 45, 90 triangles? No, it's going to be every 45, 45, 90 triangle. That's why it's a special one. So in a 45, 45, 90 triangle, we'll say the hypotenuse, okay. Hypotenuse is square root 2 times as long as each leg. It's square root 2 times as long as each leg. Now, I want you guys to draw this map with me. Okay, I'm going to draw a map on here with this triangle, and I want you to draw it with me, okay? Now, bear in mind, we'll have to do a couple things here. It's not a ton, so you'll have plenty of room, but just don't write like super massive, okay? So, if this leg here is x in a 45, 45, 90 triangle, what do you know about this leg? It's also x. Now, if I was trying to go from this leg to get to the hypotenuse, what would I have to do to this leg? The length of this leg? Double it? Is that what it says? Multiply by what? Square root of 2. Multiply by the square root of 2. And what would x times the square root of 2 be? X square root of 2. Just like how we had like 7 square root of 2, 6 square root of 2, 12 square root of 2, x. And then this would be x square root of 2. We multiply whatever the leg is by the square root of 2. So now if I wanted to go the other way, say I was given the hypotenuse and I had to find the leg. How could I do that? Tyler?
Because with the hypotenuse, it's kind of it's going to be the how can I explain?
You want to phone a friend?
Yeah.
Okay, Kaylee.
X squared, is it?
No. So
Leg.
how are we going to get rid of the square root?
Leg.
Divide it.
Divide. What do we do to get there? Multiply. To get back, we'll do the opposite. So we'll divide by the square root of 2. We'll do the opposite of that. We'll divide by the square root of 2.
I cannot believe I could not put say the word
Okay,
divide.
they're inverse operations, so do the opposite of one thing, we have to use the opposite. I know, but I wanted to see Mr. Cossel dance.
You're supposed to stop. You're scaring the children.
Okay. So to get from the either leg, I could have drawn this for either leg, right? To the hypotenuse, you multiply by the square root of 2. To get back, you do the opposite. The inverse operation for multiplying is dividing. So if we multiply by something to get there, we'll divide by the same thing to go back. We'll divide by the same thing to go back. Now, that's the map I wanted you to draw. You don't have to write this next part here. So if I did mathematically x times the square root of 2 divided by the square root of 2, what could we do here?
You get a leg.
Not cross multiply, but cross them out, divide them out, simplify them out, and just be left with x over 1, which is just x, right? So that's the math behind that. Questions on this map thing, okay? I really want everybody to have that. It's like a really key thing for this section. Okay, like if you're gonna remember one thing or one of two things from the section, this is the first of the two things to remember. Okay? Yeah.
Oh, no, never mind.
Okay, good stuff. Okay. Example 1. So we're beneath this. Solve for x without using the Pythagorean theorem. I want you to do A and B and solve for it without doing the Pythagorean theorem.
Alright, so you times 18 by 2 and you do 36.
Nope. What does it say? Multiply by.
Square root of 2.
Yeah. Is that the same thing as normal 2?
Yeah.
No.
2 is the same thing as square root of 2?
No, you gotta find it. So it'd be 18 times square root of 2. That's the answer?
Ah.
So then that half of 18 is
Oh, okay. Alright, hey. So, on this first one, what are we given? The leg or the hypotenuse? Leg in a 45, 45, 90 triangle, right? You know it's 45, 45, 90 because it's isosceles in, right? So these have to be 45, 45 degrees, the angles. So, how do we go from the leg to the hypotenuse? So we take 18 times the square root of 2. Can we simplify this anymore? No, we're done with the first one. Yeah. Yeah, right?
We have a lot of these on our homework.
Yeah,
Yeah, it's front back, 2 page.
But is it like all like
Double
this?
sided.
Okay. Nice. Okay, hey, on B, what are we given?
The hypotenuse.
Hypotenuse. How do we go back to the leg then?
Divide by 2.
So we take 18 over the square root of 2. Do we want to leave our square root in the denominator? How do we get it out of the denominator?
Solve.
Multiply by,
Negative. No, not negative.
you multiply by,
Reciprocal.
okay, not the reciprocal. Okay, so if we multiply something by 1, does it stay the same? Okay, when we multiply something by 1, do we get the same number? Like what's 5 times 1? 5. Okay, like 20 times 1 is just 20, right? Okay, we get whatever number it is. So if we don't want to change the actual mathematical value, so we can't multiply it by any number other than 1, because otherwise that's going to change the actual value of it, right? Okay, so we got to think about that. So we need to be creative about how we multiply this by 1. What is 5 divided by 5? 1. So is this just another way to rewrite 1? So would the square root of 2 over the square root of 2 just be a fancy way of writing 1?
So it'd be F.
It'd be a fancy way of writing 1, wouldn't it? Now how do we multiply fractions? We multiply straight across. So we're just multiplying by 1, just in a fancy way. What's 18 times the square root of 2? Just 18 times the square root of 2. What's the square root of 2 times the square root of 2? Square root of 2 times the square root of 2. Square root of 4. And what is the square root of 4? Normal 2. And can we simplify this anymore?
Yes. You can divide 18 by 2.
18 and the 2. Because this is not underneath the radical and this is not underneath the radical. So you get 9 times the square root of 2. And is there anything on the bottom? Just the 1. We don't have to write that. So 9 square root of 2 is our x. So that one was a bit more, but I think once we get used to it, that'll be a lot easier than that one was. Okay? Does anybody know why I chose square root of 2 rather than 5 on this one?
Because you were dividing 18 by the square root.
Because we're dividing the 18 by the square root of 2. We choose whatever number we're dividing by, whatever radical we're dividing by. Because on the denominator, what ended up happening? Square root of 2 times square root of 2 is a regular 2. So whenever you multiply by the same square root, you'll get rid of the square root on the bottom. So you have to do it by the same one. Kaylee.
I thought you like always had to do it by the square root of 2.
If it's like the square root of 3 down here, we multiply by the square root of 3 or the square root of 3.
Then where's the square root of 2
That's-
coming?
No, that's dividing by the square root of 2. So here, on this problem specifically, we're dividing by the square root of 2, so that's the number we chose in our fraction. That won't always be what we divide by. In a 45, 45, 90 it will be, but in other triangles it won't. So for this example, it'll always be this. Okay, go to the back. Go to the back. Go to the back with me. Please and thank you. Alright. Equilateral triangle ABC. Equilateral triangle, what's that tell us? All the sides are congruent and all the angles are congruent. So we know all these angles are what measure? 60 degrees. Okay? And CD is an altitude. Altitude, what's that mean? It goes from the vertex to the opposite side. How? Makes a right angle. Very good. And it kind of splits this triangle, right? Okay. What's the measure of angle A and the measure of angle B? 60 degrees.
Oh.
Because these are all 60-degree angles. Okay. On 2, what are the measures of angle ADC and angle BDC? 90 degrees, because CD was an altitude. So these are both 90 degrees. We know that. So what's that mean the angle of ACD and the angle of BCD have to be? Owen? 30. How'd you get 30? You cut the 60 in half. Now wait, how do we know this goes through half though? That's not part of our altitude property. Because we know 60 plus 90 plus 30 has to equal 180. So this one has to be 30 because this one is 60 and this one's 90 already. So our triangle sum theorem states that our third angle has to be 30 because 60 plus 90 plus 30 is the only thing that equals 180. So this one's also 30. And so it ends up being cut in half. Really.
How did you figure out that it was 60 degrees on A and B?
It's an equilateral triangle. So all the angles have to be the same. Good question. So, do we know that could these triangles, triangle ADC and triangle BDC, would they be congruent?
Yes.
Okay. So we can. How can we determine that? Do we have an angle, angle, angle congruent? One half. We have to have at least one side, right?
Angle side.
Do we know a side?
They're congruent to the middle.
The middle's congruent to itself. Do we know that CA is the same length as CB?
Yes.
How do we know that? It's an equilateral triangle. So we could know by. So are these congruent? Yes. And you could know by. We don't.
Yeah, because it's going right to the half.
We don't know that's the bisector because it's an altitude, not a median. So by that we can't do side, side, side. But we could do side, angle, side. Or you could do angle, angle, side. Or you could do angle, side, angle. You could do any of those three options, really. Okay, so you could do side, angle, side, angle, side, angle, or angle, angle, side, angle, side, or angle, side, angle, angle, side, angle. Okay, there's a few ones you can do. So after all, if we know the triangles are congruent, then now do we know that AD is going to be congruent to BD? Yeah, because, so yes, because corresponding parts of congruent triangles are congruent. That was a mouthful.
What?
It's something we learned way back in chapter 4. That's saying corresponding parts that go together of congruent triangles, parts that go together of congruent triangles are congruent. So because AD corresponds with BD in these congruent triangles, they're congruent.
Do we look at
Come
GT look?
up with a word for that or something.
Yeah, we like okay. And so what do we know about AD compared to AD and DB compared to AC and BC? What do we know about the length of this AD compared to the length of this side? What do we know about the how would it be half? The entire thing is the same length as this and this, and if these are congruent, then it is cut in half. So we know that this and this, AD and BD, must be half of this, right? Okay. So this is 60 degrees. So if we look at just one of these triangles, like we cover up this right one here, okay? I just have my audio over there. You can only see the one left now. We have a 30, 60, 90 triangle, right? Triangle with 30 degree, 60 degree, 90 degree angle. And we know that if this length is x, then this length is what?
X squared.
Not x squared, it was 2x. It was double it, right? So if we know that this one across from the 30 is x, then we know the hypotenuse of this right triangle here, hypotenuse across from the right angle, has to be double that. And that's actually going to be for the first part of our 30, 60, 90 theorem. So in a 30, 60, 90 triangle, the hypotenuse is twice as long as the short leg. We'll call it the short leg. Now, why aren't we just calling it the leg here?
Because there's two legs.
There's two legs, and are they going to be the same length? No, it's not an isosceles triangle. So 45, 45, 90, 45, 45, 90, legs had to be the same length. Because it was isosceles. The angles were the same, so those corresponding sides, opposite sides had to be the same. Here, are these angles the same, 30 and 60? No, so their sides are not going to be the same. Now, which one of these sides is going to be bigger, the one opposite 30 or the one opposite 60? Yeah, the one opposite 60 is going to be bigger, right? Because this is a bigger angle. So we call the one opposite 30 our short leg. We call this our short leg. Okay? So we're going to draw the first part of the map, and then we'll come back to it more in a bit. So let's draw the first part of the map here. So if this is our short leg, I'm going to write that in there, short leg, first of all. Because opposite 30 degrees. That's our short leg. We know this to be our hypotenuse. You can write that in too if you want to just abbreviate it HYP. If our short leg was X, what was our hypotenuse? 2X. And we did what operation to get there? Multiply by 2. Because if we remember on our picture right above this that you have, this was half of that side of the big triangle, half the side of the big equilateral triangle. This is the whole side of the big equilateral triangle. So that means if we were going back from the hypotenuse back to the short leg, what would we do? Divide by 2. The opposite of multiplication, which is division. Once everyone gets this down, let me know.
Honestly, this isn't as bad as I thought.
No. I really do like this section, yeah.
Why is it a 2 and not?
Okay.
The
So
last one.
the reason is because this was that first pattern, that was the pattern we discovered. Whereas this, if we look at this, does this have to be half of this? Yeah. So that's why it is. Where these like this has to be half. So we have a whole square root 2.
Yeah.
Square root 2.
How do we see
So it's
it?
just-
Use like the,
That makes sense.
Yeah, because the hypotenuse.
like it's the
All
same
that.
way as the
Yeah,
other
the desks are a little bit more spread out.
When you're an architect, I'm not gonna be an architect. I'm stuck. Oh, I'm not gonna be an architect.
Alright, going right below this, we're gonna finish that in a bit after we do some more discovery. Okay? So here, on number 1, what length are we given here? Hypotenuse. What could we find with the hypotenuse?
short leg would be
Divide by 2 to get the short leg. Which one is gonna be the short leg?
the bottom.
The bottom. How can you tell us the bottom?
Cross from 30.
It's across from 30. Very good. So we can find our short leg from our hypotenuse by dividing by 2. So I want you to actually don't circle that. You can find the short leg with 6. So I want you to go ahead and find the short leg or hypotenuse in 2, 3, and 4, or 2, 3, and 5. So I want you to find the short leg or hypotenuse in 2, 3, and 5 right now. You have the ones where you have one number given. The ones where you have one number given. If you have any questions, please let me know.
Wait, you said only do 1 through 5, right?
So on the practice test, is there any question usually we give?
There's like 3 questions out of like 10
Which leg are we
for the Spanish test.
Oh, I didn't
Is
even
that
know.
all of
That's
them?
why.
Okay.
Yeah, I thought it was like. If people say it's not, they're lying.
Everyone.
Okay. So on 2, what are we given? On number 2, what are we given? Short leg. So what can we find? Hypotenuse by Ian. And we get, on 3, what are we given? Short leg. How can we find the hypotenuse, Gage? Multiply by 2 and get, on 5, we're given the what, Faith? Hypotenuse, and it's 100. How could we go to the short leg? Divide by 2. We know the short leg because it's across from 30. Pythagorean theorem to find the third side on 1, 2, 3, and 5. I want you to use the Pythagorean theorem to find the third side on 1, 2, 3, and 5. Use the Pythagorean theorem and put it in simplest radical form. So you use your Pythagorean theorem to find the third side on those 4 in simplest radical form. Yep.
Oh,
Might not be okay. Really can help you know what you're doing. Yes.
This one goes to. Yeah, remember for before? Yeah. Okay. Okay, so 3 to 6 stays as 3, right? And then 1 over 2 times 2 becomes 2 over 2.
Yep. So it's just like first rate.
X 3 times 2 equals 6, so y equals 6. And then
Yep. 3 over 3.
which is 3,
3 over 3, which is 1.
and then 1/3 of 18 is 6. Oh, now I have the same radicand, same call it?
Not radical.
Radical? Same,
It's not.
same
Radical.
radical.
Not radical. But no, it's not a radical.
Okay, so
You have the same. You have like terms.
the 3 minus 1 becomes, so it's 2 xy.
Yes. Yes.
That's it.
Hey.
Okay.
Yes.
I'm a watcher.
Alright. Hey, so what did we get on this first one?
Square root of 3.
6 square root of 3. After all that work, we got 6 square root of 3. Did anybody finish the second one? Okay, Haley, what'd you get?
4 square root of 3.
I agree. Anyone do the third one? Faith? Are we noticing a pattern?
Oh, I didn't notice. I should have noticed.
What are we noticing?
Everything's the same as the leg.
The short leg, but what do you do to the short leg?
Give it
You just give it, what operation? Multiply it by the square root of 3. So what's our fifth one going to be? We have our short leg is 50.
5 square root of 3.
50 square root of 3.
Job.
So, we notice this pattern, we go back to this map up above, and the long leg, we'll call it the long leg, across from 60, is square root 3 times as long as the short leg.
Why didn't I notice that?
Wow.
Okay. So if we go back to our map here, we're going to call this one our long leg, across from the 60. Oh, that's so sloppy there, long leg. And so if this is x, what would this one be? The long leg. If the short leg is x, what would the long leg be? X square root of 3. What do you do from x to get to the x square root of 3? Multiply by the square root of 3. So to get here, to complete our map, multiply by the square root of 3. How would you get back then? How would you undo the multiplication? Divide by that same thing, the square root of 3. Are these patterns? Can these patterns be pretty nice then if we catch them? I think so. Okay, let's jump down to. Does everyone have this map first of all? Does everyone have this map? Katie, what's your question?
That how come on like the number 5,
Mm-hmm.
like the short leg was 50,
Yep.
but oh it's 50.
If you do it correctly, yeah.
Oh, I didn't do it correctly.
Okay. Did you do 100 squared plus 50 squared?
I did. I got 5 square root of 2.
Oh.
So yeah, I did it by 25.
Oh.
You probably just left out the arrow.
So
How would you do 4 and 6?
you'd have to be given a length.
Okay.
So I was gonna go through and give us a length if we had time. We don't. So we're gonna go down to the bottom where it says example 2. So on this bottom where it says example 2, if we can we find the value of a and b without using the Pythagorean theorem? Yeah. What are we given?
15.
Which is the
long leg.
long leg. We're given the long leg. Can we go from long leg to short to hypotenuse? We can go straight from long leg to hypotenuse? No, that's not on our map. We have to go through where? We have to go to the short leg first. So
Divide by radical of 3.
you have 15 divided by the square root of 3. That's not simplified though. What are we going to multiply this by to get the radical 3 out the bottom? The square root of 3 over the square root of 3. Why isn't it the square root of 2 over the square root of 2 this time? Because we're dividing by the square root of 3. So 15 times the square root of 3 is just going to be 15 times the square root of 3. And square root of 3 times itself is what?
The number in the radical.
Square root of 9 or just normal 3. You get the number inside the radical here.
5 square root of 3.
So we can simplify that to 5 square root of 3.
And that's
So
A.
that's A. And now how can we find B? Multiply that by 2. That one's a bit easier. So what's that going to be?
10 to square root of 6.
Not 10 square root of 6. So if you do 5 square root of 3 times 2, you're just going to multiply the numbers outside the radicals together.
Oh.
10 square root of 3. So that would be our B. So our A is 5 square root of 3. Our B becomes 10 square root of 3. If we look at example B, or letter B on this one,
Exactly. No.
okay, what are we given? Square root of 2, and we're given the short leg. From short leg, can we go either direction? Yeah, we like short leg the most. We like being given short leg the most. How do we go from short leg to long leg? What is the square root of 3 times the square root of 2? Can we simplify that anymore? How do we get from short leg to hypotenuse? Normal 2. So what's our answer? Can we simplify that anymore? That's your answer.
Yeah.
No, like you guys are like, no, and I'm like, you don't understand like how nice this one actually is. No, like special right triangles are the best. Like I had printed these off earlier, and like Mrs. Ayala was looking at it, and she's like, I want to do this worksheet. And like Mrs. Harding looked at her like she was like, you know, the Antichrist or something. And like she's like, no, like you don't understand. Like special right triangles are the best. Like they're not bad at all. If you can remember the problem here, the issue with special right triangles is remembering the pattern. You have to remember the pattern. If you don't remember the pattern, you're sunk. But if you remember the pattern, then you suck. And you can do the math, we'll be fine. That's the hard part about special right triangles, is remembering the pattern and catching what we have. Remembering the pattern and catching what we have, but they're actually just all about shortcuts. When's that homework going to be due? Next class, which is Friday. Hey, so I know I don't have any don't do's on here, but